Okay, I think we are now live. So
What?
people can hear us talking, but they should only be seeing
Uh-oh.
the screen there. It says live, so now you're live.
I'm
You're on
live.
the
Okay,
screen.
I'm caught live turning off my phone.
Oh yeah, we should. Everybody silence your
I'm
phones.
putting my phone on airplane mode. Okay.
Just like I tell people in class, put your phones on silent now.
Okay. It's on airplane mode.
You're
Is everybody
live.
there? How many people we got?
Well, we won't see them. I don't see them in the chat thing. I don't know if
We don't
can-
know. We
Yep.
don't know if they're there or not.
Yep. I can't tell, but we'll find out. So we are live
Okay,
though. So
we are live. Okay.
Yep.
Well, I don't want to get right into it if they're still coming in. If we've only got one person.
Well, that's why they can like record and watch later.
Oh. Okay. You want to get right to it.
Yeah, it doesn't tell us here how many people
Okay.
are on there.
Well,
at least
we
not in
don't-
our chat window.
Okay. We don't know unless they chat to us.
Yep.
Okay. So speak up on the chat just to let me know who in the heck's there.
Yep.
And then we'll
Talk about
take a minute and just talk about the kit in general. Of course, everybody knows that I went to the store
Okay.
looking for tins and I found this this one right here. I found this Cento.
Yep. Keep going. I'm just.
Is that the right thing? Okay, I
Yep,
found
yep,
the
yep.
Cento tin, and it was just plain lovely, as they say in England. It was a lovely tin, one of the prettiest tins I've seen because it has all the painting on the side. So that's when I designed the kit, and then I discovered that this one here is not very popular in stores. The rolled anchovies. So anyway, I had to buy a ton of those things when I found them at a closeout store. But then this is the most popular one, which is the blue flat anchovies. Apparently, you put flat anchovies on your pizza. So lots of stores have this one here, the blue one. So when I made the first kit, which I don't happen to have with me, the Livestream number 4, which was the receiver with the no solder, that was in a red board with yellow lettering to go in this tin, which everybody got. Now, this latest kit is, of course, a blue board that fits on the blue tin, so it's kind of nice. And of course, we had the receiver. The Cento Receiver was the third live stream. This is now a x-1er transmitter.
It's not showing the web page. Hang on. No, go ahead. Keep talking.
Okay, keep talking.
Keep
Okay.
talking.
So now we have, with the completion of this kit, we'll have a receiver and a matching transmitter in a complementary packages. Just kind of pretty. And of course, I chose the x-1er because it's getting back to the basics and it's relatively simple. It's wide band, so you can actually change it very easily to go to any band you want in the HF range. Your 80 through 20.
That's what happened. You moved on me. That's why you weren't
What?
centered. Yeah. No.
I didn't move.
You were in a different place than when we were setting up, but that's okay.
That's right there, right in front of me. See that? Okay. So anyway, so that's why we got the blue can. Now, I don't have lots of blue cans because I bought tons of red ones. So I put a red one in, and I did here's an example of a built low pass filter board on the red prototype board. Now that fits on the red can that I sent out to everybody. So that's a freebie. And then you have to go to the store and buy a blue can if you want it to match. If not, put it in a red can. I don't care what you do, as long as you build it and play with it. Okay, so we will get to the fact now. I'm going to have, here's one all built. We need a good close-up shot of this. Okay. And you'll see that, all these things are standing up on the pads, and that's very similar to Manhattan construction. I mean, that's how you make Manhattan construction. You put the pads down on a board, then you link everything together, and they're standing on pads. In Limerick Limerick construction, I put the pads on a production board, and then I put all the interconnections. So the pads just have places for the parts. You don't have to do the interconnect. But as you can see, okay, here we go. I got the angle shot now. There's all kinds of things, even resistors. There's nothing that's really flat on the board like like a typical kit. We would build, we would put down the laid down parts like the resistors and the diodes and the sockets, and we build from low to high. In this particular case, because everything is high, everything is in the way, what you have to do is you have to start on one end of the board and build from one end back. So as you're building, nothing gets in your way. Okay, so that's how we're going to build this. So it's not the same as what we normally would build, but this is how you'd have to build something that's point to point. You can't put stuff down and then try to get in the middle. You gotta go logically from one end to the other. So we're gonna take a board. Do we know how many people out there are wife?
Okay. Yep, there's a number of checked in.
Okay.
Tony, Stephen from Tennessee.
Okay.
David from Southern California.
I don't know how many people have done their homework. So let's get a shot of the homework parts here. In this type of construction, where we have the pads, when you put down a part, it's best to have this little. Let's see if I can get that.
You might over on this side. Yeah.
Okay. There you go. See the little feet? Okay. When you bend the parts down, instead of just having a straight lead, you want to put just a little bit of a foot on it, because when you put it down on the pad and then you cover that foot with solder, that gives you the best mechanical connection from pad to the part, so the part just doesn't pop out. And it's not so much pop out, but if you have a bad solder joint or vibration or something, and it's not really a good connection, it becomes a point of contention. I mean, a place where it can possibly break free. And by putting that pad on there and covering that pad with a lot of solder, that really eases stuff falling off, okay, at a future date. So when you figure out what parts are what, like for instance these capacitors, they are all they're already, okay, I gotta find it. I'm looking at it now. Okay. They are already 0.2 inch spacing. So all you gotta do is bend the bottoms, because if you look at the board, I make all the capacitors at 0.2, let's see, 0.2 spacing. So they go from square to square. See that? Resistors go, here's a 0.4 spacing. So it jumps over. So it's an alternate pad. So if I can get that in there. Oh, no, wrong way. Okay, there we go. Okay. So you can see that 4/10. These are in essence 2/10 on center. All right. So by putting little feet on on resistors and capacitors, and the choke, and some of the resistors are going to go right down to the board. There's two resistors, the 100K. Pull up the homework sheet, would you?
Yeah, I was trying to, and that was where I was having problems.
Okay.
Yeah, I'm not able to get it up.
Not able to get it on? Okay.
Not at the moment.
Okay. Rats. I don't have a copy of it, but on the homework sheet, I showed which parts need to have little feet on them, which parts are bent at 0.2 inch spacing. So we'll just have to take it as we go along, and I just pretend like I'm
going to see if I can get that working, but
okay.
For the moment it's not.
All right, so we're going to assume that we're just going to start, and I will. I'm going to start with the connector end, the output end of the board.
Okay, hang on, I got it now.
He's got it. Okay.
So down here was the homework.
Yeah, the homework prep. Okay.
And
I just want to pop it up.
Is.
Okay,
yep.
there it is right there.
Yep.
Okay. And you can see I've laid out all the parts, and then knocked a little list of which ones need feet, which ones are left alone.
And is that right in here?
Yeah, there's they're all bent at 0.4, and they have the little feet on them. Okay. So we have the SIP socket is cut to a
did I pass? Oh, this right here. The
Yeah.
3-pin section of the
Yeah.
SIP socket.
is used for a crystal socket. So
Okay.
I can't get me my. Okay, so there's a 3-pin piece of the SIP socket for a crystal socket. You notice that the center pin is cut because it's not used. Okay, another 5-pin piece is used as a socket for the resistor. Okay, and again, the resistors that plug in and out of that, which is the 1.5K, the 2.2, and the 4.7K, those you might want to change to increase the power of the output power of the kit. So that's why they're easily changed with a socket. So those are just basically straight with no feet on them. Okay, so we're going to start, and I'm just going to try to slowly go through this thing, and if you can't keep up with me, I'll try to go really slow. Okay, and that's why we're doing a live stream, and we're doing the save. So right afterwards, it'll be up on the site, and you can just follow it at your leisure. So
that's the plan, right?
That's the plan, Stan. So the first thing, if I start off going down, I'm going to go left to right because I'm a right-handed solderer. Okay, so I'm going to solder the left side of the board, then the right side of the board, and work my way down. Okay, if things are so, the left side of the board is the 2-pin screw terminal block. Okay, and when you can look down there and see where the wires go, that wants to be up. Because, see, ordinarily you would put that in the holes on the circuit board, okay, and you'd solder the back side, but you notice we don't have any holes on the board, okay. So what you have to do is you have to lay it down at an angle, okay, and just solder the pads to it coming in from the side. So to put a part down the board.
Can you move your finger out of the way there,
Oh.
or turn it? Yep.
Okay, let me see if I can.
There we go.
Okay,
Yep.
Here we go. I'm gonna hold it with my pliers. Oh no! Disaster strikes. Earthquake. Okay, is it in the right place or not? Okay.
Yep.
All right. Well, sorry about that.
The pliers not so much, but
my pliers were too close to the tripod of that camera. Okay. So here I got, and what I can do is show now without my fingers in the way. You just lean it into the board.
Yep.
Okay. You lean it into the board, so it's going to be at an angle. And you don't have to pay for those. They have some that are on a 45-degree angle, but this one we're just doing a 90-degree, but we're soldering at a 45-degree angle. So when you do multi-pin parts, you only want to put solder on one pad. So I'm gonna put a big gob of solder on that pad. Okay. And so now I'm gonna tin that one lead, that same lead on that part. You notice I'm using my pliers with the rubber band trick to hold onto the part, so I can put a decent amount of solder on there. And I don't want to overdo it because I don't want to screw the part up. Now I got to turn this. I got to do that with hold it in my left hand, so I'm doing it backwards now. So I can now put it down on the board at an angle and reflow the solder on that pad. And let it cool. And then take the pliers off. And now I can do the other side. I'm going to put a little down pressure to make sure that it's all the way down touching the pad. And I will
try not to burn your finger on the screw.
Yeah, try not to burn my finger on the screw. And sometimes what you have to do is, now I can go back. Now that side is soldered nice and neat, I can go back and redo the first one. That might have been, and what I'm going to try to do is I'm going to try to wick solder back up that lead. So there it is. There's the first part. Okay. All right. Okay. So there's the first part on there. And now we can get to the screws for the screw terminals, and there's the leads coming up for the power supply. Okay. What's going on here?
Trying to move the camera to a better spot.
Right. Well,
for your.
Yeah, now you screwed up all my tools.
You're welcome.
Okay.
No, you keep going.
Okay. So there's our first part. I mean, it's not quite as clean looking as if I had a circuit board, but then again, there's an added advantage to this, and I'll talk about that later. So the next part is down here is the RCA connector. So here's the output RCA. Normally we'd have the holes. We're not going to have any holes now, so I'm going to. If you look real closely, I did a little bit of a pre-bend on those. Let's see if I can figure out how to show that.
Yep. No, it was fine. You were good where you were. More to your right. Yeah.
There it is. See, there's a little bit of a arc to that. They come out straight, and I just sort of bent them over a little bit to help with laying the part down. And I'm going to cut off that little foot. I'm just going to cut that little stub off. And that helps me lean it more. So I can, again, see, I can lean it fairly nicely on there. So I'm going to put another blob of solder on one pad. I'll load this into my...
Feel free to post your questions
Yeah,
in
if
the
you
chat
got questions
as
or
we
comments,
go.
let us know.
Otherwise, we blindly just go on, and
Yeah, we keep on going.
if we'll have a kit built, and you'll be still having that question.
Yeah, but that's okay. I mean, we take questions all through the thing, and then, but you can keep up by watching the replay later on.
Instant replay.
Instant replay. So again, I'm using my little pliers to hold onto the part, and with my rubber band, and I'm going to put that one pad down and move that thing and center it on the pad. Looks good. I'm waiting for it to really cool down. I don't want it to move while it's in the cooling state, because that will fracture your solder joint. So I can take that off, and again, I'll solder the second pad. I'll lay lots of solder on top of that pad and make a good covering over that foot. Wait for that to cool, and then go back and make sure I've got the same good load of solder on that first pad and covering up the foot, and there it is. So, yeah, good part. So there it is. There's 2 parts on the board. Boy, we're really cooking now. So the next part is a 0.1. Remember, on these Billathon boards, I put the part values right on the circuit board. So in the silk screen, there's a circuit component. It says capacitor, it says 0.1. So I don't have to go look. I don't have a piece of paper in front of me. I don't have a schematic. I don't have nothing. I'm just going to go get my 0.1 microfarad capacitor. I'm going to put that up in my pair of pliers with my tape on it. I mean, my rubber band.
Then you're going to slide the board back down over the little piece of tape that has an X on it.
Oh, there we go.
There you go.
Is that still working? Is that still working for us? So again, I'm gonna put solder on that one pad that's furthest away. I'm gonna solder the same foot. Get it tinned. So when I put this on, the foot is tinned. Now just hit that, and let it cool. And there it is. So I'm going to make sure that second foot is centered on the pad and standing up all by itself now, and I'll cover up the second pad. And you notice I'm putting a goodly amount of solder on that thing to make it good. Let's see if we can get up in there close. Right there. You can see there's a good amount of solder completely covering that pad and the foot of that part. And you see how it's wicked up onto the lead? So I know I've got a good connection because I've got a good wick on it. Okay, so I got another 0.1 up above. So just, again, I'm going to turn the board to get a really good spot so I can get in with my iron and my solder without competing against any other part that's on the board. I'll load that thing into my pliers. I'm going to use my little Cobra, and I'll load up that lead with some solder. Put that on that first pad. We getting a good video of this?
Yep, I think so.
All right. And I reflow that solder, and I see that thing go down in there. Make sure it's not sticking off Give it a little cooling air. Now I can take this and just form the second lead and tuck it in there so it's on the pad nice and neat. Perfect. And go in there and solder the second lead. Beautiful. I think we're fine. Any questions? Comments?
No questions yet.
Swear words? Any swear words
I
coming
haven't
from the
seen
audience?
any of those either.
Okay. So the next one here is the radio frequency choke. And I've got a 1 brown, black, red. So that's 1 millihenry. I don't know if that's overkill or not, but ordinarily the original kit, I got a print of the original description from Spratt for the 1er.
Yeah.
It was like in the late 80s. I'm gonna have that posted on my site when I get home later tonight. But it just talks about the radio frequency choke is just making sure that RF doesn't get up in your power supply. So it could be just about anything. And I just happen to have these things laying around. So to again get that lead tinned up. Woo! So in this case, I'm gonna actually hold on to the other side lead. So the body of it's not a good place to hold on to that choke. I'll come in here and nice connection. Now, I'm not saying this is the most beautiful construction in the world. If anybody's been around the my me squares and me pads and stuff, if you go to AA7EE's website, Dave Richards out in California, he makes beautiful stuff from scratch using
You
this
said
kind of
AA?
AA7EE, I believe is his call sign, Dave Richards. He uses the real live, the me pads and me squares, and he makes beautiful. Yeah, there's a good example of it right there. Look at that. It's gorgeous. Okay, so there's 1, 2, 3, 4, 5 parts. 6, 7, 8, 9, 10, 11, 12, 13. We've got 1/3 of this kit already built.
Yep. Well, it goes fast.
It really does go fast. You're not futzing around with, and you don't clip any. Well, you gotta do your homework first. Okay, it goes fast when you do your homework. Okay, so the next one is this this VN10LKS transistor. Now, this little puppy is the heart of this thing. It's a MOSFET transistor, and they're no longer made, or they're not in production. So you have to find old ones. And I actually found this transistor at a closeout place, and I bought like 1,000 of them because I knew it was the operable one inside the 1er. So I've been sitting on this transistor for several years now, waiting to do this little 1er kit. And this happened to come around, and I think that, shoot, I think I just moved that transistor. I think I gotta use my my magnifier. Here it is. Oh, this is Steven's magnifier. That is the 2907. That's not it. Oh crud. Let's see, what's this one? This one got up in here somehow. Oh, here it is over here. It slid over with this bolt. That should be a... Nope. Oh, I think that's over here maybe. There we go. VN0610L. Okay, so here's the transistor. Now, if you look, these have got like a little, almost like a delta wing shape for the, what is that? Is that the stealth, B-2 stealth bomber? What that thing looks like. So I'm going to just use this pad over here, to this pad here where it doesn't go, just to basically, if
Your
you
hand's in the way when you
yeah,
do that.
well,
so-
I'm gonna hold it with my pliers in a minute as soon as I pre-bend it. Okay, so now I can hold it with the pliers and get my fingers out of the way. Okay, we need a good close-up of this. I don't know if I can do that. Okay. Okay, here we go. I think this is it. Now see this pattern right here that looks like the little first, second, and third base? That transistor, if you look, there's a spot where you can actually go across all three in a straight line. Okay. So that's how
And the flat side of the transistor is towards the empty spot.
the flat side is towards the empty spot, and you can see the silk screen on the spacing. Now, if you look, that the problem is if you do that by bending those two leads out, they become shorter than the middle one. So I'm going to pull that middle one.
Lower it down a little bit.
Well,
no, and then
okay.
to the
So I'm going to pull that middle one down a little bit. So now it sort of sits on a tripod on those three pads. And there it is. I can see it. Okay. So now I'll do the same thing while I'm holding this. I'll tin that first lead. And I've got that pad loaded up with solder, so I'll do the first one.
And then you'll move the board back over the X.
Yes. Okay. Okay, I'll move the board back over the X. Okay. Now I've got that part secured with the first lead. I'm going to use a little screwdriver. Use a little screwdriver just to basically massage these leads onto the pads so that they're sort of in the middle of the pads. They're not off the pad. Okay, and I guess you have to do one at a time. So I'm gonna do the back pad next. There it is. Okay. Now that I've got two out of the three leads, I can do a little bit more hard massaging and get the third one where I want it. And then put solder on the third lead. This is the hardest part of the whole kit, is putting these transistors down, because I got three leads. Okay, there it is. No big deal. So we're starting from the top, going down bottom, and just taking it one part at a time. So over here, we're going to rotate the board, and I see I got another transistor up here, which is the... Now, in this case, you'll see there's two sets of letters. There's a ZTX 751 and the PN2907A.
Can you lay the board flat down?
Oh, okay.
Yep, now point at it.
Okay. Up on top side.
Yep.
Okay. It says ZTX 751, and it says PN2907A.
Yep.
Now, there's been several prints of this circuit. I mean, the ZTX was the original transistor that they used in the original Oner way back. And that was in the 80s. In fact, I used that same transistor when I did a robot project for educational computing. It was a very popular transistor in its day because it had lots of current capability. But they're hard to get a hold of these days. But I did find some, and I included some in the Billathon kit. So
you don't have the schematic here, do you?
I do not.
Okay.
Okay. I make note of it in the site, but I haven't put that document up from Sprat.
Yep.
So I will let's see. I'm gonna put the 751s in here. The 751 and the 651, which is the original. ZTX was the part from Ferranti Semiconductor. ZTX. It's very their lettering is about the toughest that you've ever seen. I think that's the 651. Let's look at the other flat one. This must be the 751. They're like PNP and NPN. And I really got to move this light around to be able to see that. It's terrible. Yep, there's a 7 on there. Okay, that's a 751. So that's going to go up here in the top. So I'm going to do the same thing. I'll just splay those out a little bit. And look at the flat side, which is there. And then I'll move the other one back. So I got my little tripod. And I'll set it in there. And looks good to me. I'll spread them out a little bit further though. Okay, so this time I'm going to do the I'll try doing the back pad first. Clean my iron. I got a lot of crud on it. Okay, and that's the importance of the pliers with the rubber band on it, because you need to be able to prep these parts as you go along. So it's handy. I'm going to tin all 3 leads while I got the part in my sights. And then I'm going to go sneak in the back side. Let's see what I got here. Oh, that's not it. There it is. Okay. Okay, so I got the back side in there. That's good. Okay, get one side. Now, if you notice, when I'm moving my iron, I move it up and down the leg of that thing, helping the wick to solder up the transistor. You don't want to overheat it too much, because you can get the heat in the transistor and ruin it. But you do have to try to whip that solder up that part. So there we are. We got that transistor down. Now we got a 1K resistor. That is one of them that is permanent. You don't ever have to change that, because that's part of the keying circuit. So we don't change that to get any different power out of it. So I set it down right on my solder. Any comments from the peanut gallery yet? Nothing?
No, people are pretty quiet.
Is anybody actually building it with me, or are they just watching?
That's a good question.
Yeah, come on,
know,
fess up.
Some
Is
people
anybody
like
building?
to just watch.
Yeah, some people just like to watch. Is anybody actually building it? Okay.
I think I built one while you were building it, but after that, it just was too much going on at the same time to do all of the above.
There's one lead, and here's the other. I'm just going to dress it up and get it nicely squared up on the pad, and solder that in. Okay.
Move the board back down over the edge.
Move the back down. Okay, back down there. All right.
There's just not other parts to keep you in the zone,
Yeah.
right?
Yeah. Okay. Now we can add the key is not on the circuit board. We have to use a little piece of wire for that to go out to the key jack. And if you've got your well, I already prepped mine, so I'm gonna go get the prep unit.
You're just gonna unsolder it from that
I'm gonna
one.
unsolder it from the other one. Okay. Because I wanna show the prep unit in all its glory. So I'll start with the actual jack that's in the kit. And the three, you can see there's 5 connectors on there, 5 connections. There's 3 of them that we want, ground, tip, and ring. And the other 2 are the internal switches. So when you put a jack in, it disconnects the internal speaker. So we want to cut those off just for convenience. And it just so happens that the very back one, okay, there's the hole for the inserting the jack. So the very back one is not what we want, so I'll cut that off. And the one in the very middle, we'll cut that off. So now you're left with 3 connections. we got that is ring, that is tip, and that is ground in the very front. And there you go. Okay, so we cut the two back off, and
You're covering the whole thing up with your hands right now.
okay. Sorry, I was looking at the diagram. I wasn't paying attention to my fingers. Okay, so you can see that. There we get a pointing device. So we cut that guy off, and we cut that guy off. Those two. Okay. So then you can solder that. You can solder your ground wire to the very front, and then the second wire coming off your key is soldered to both of them. Okay, so now that commons the tip and ring. So if you if you put a set of paddles into this jack, there's a stereo jack, either the left or right paddle is going to activate the kit.
Yeah.
So that's what you get when you solder tip and ring together. Okay. So if you put a straight key in, that's typically a straight key is typically on a mono plug, but if it's on a stereo jack, it's got the ground and it's got tip or ring.
Yeah.
Maybe, or both. So in the case of here's the little key that I put out as a little transmitter accessory, and this is a straight key, and over here we have a set of plugs. This is a sidebar explanation.
Your hand's in the way.
Okay. Well, I'm going to get them. I had to
Move
take the
it
plugs out.
Move it to the left.
Move it to the left. Okay, I had to take the plugs out. My finger's in the way. But if
Move it more to the left.
Geez, I'm drifting in the wrong direction.
Yep.
Okay. All right. We have two sets of connections here. There's a 2x6, a 2x3, so there's 6 connectors there. Okay. And if you look, it says contact on the front, and it says ring, tip, ring, and ground. So if I put my jumper back between contact and ring, that means that this contact is going to go through the ring connection to your key jack.
Turn it a little bit towards the camera. There you go. Yeah.
Okay.
So that people can see which pins it's plugged into.
All right, yeah, it's plugged where it says ring on this side and it says tip on this side.
Yep.
Now, to not lose this plug, okay, I would put it off to one side. So it plugs in, but it's not making any contact to the center pin, okay, to ring. And it's not going to ground. Now, that means that you can plug this into a stereo jack and only the ring connection will engage. Now, if I put that on in a rock mite, the rock mite is going to be able to send dashes, but no dots, okay? The rock mite, when you first turn it on, it looks to see if one of the two paddles is shorted, and it assumes, oh, you've got a straight key plugged into a stereo jack.
Yeah.
So it goes into the straight key mode.
Yeah.
So if I take one of these connectors, if I take the one that's not engaged, okay, the tip side, and if I go tip to ground, now the tip on the jack is now grounded. So when I plug this into a rock mite, it says, oh, straight key, and now you're in the straight key mode automatically. So, but on a tuna tin or this thing, you don't want anything grounded because that would just key down all the time. So we put it off to one side and disable it. So that's a little sidebar. So in this case, we're going to put tip and ring together.
Hands in the way.
Ground. Okay. tip and ring together, and then ground. Now I did that with a little cable right here. Let's see. I'll show you what we're gonna do. We're just gonna. Where's my? Way over here. Okay, so I'm gonna just go with one side of this thing. Okay, so here's my little cable. I'm gonna tin those leads on the cable. Solder now. Okay, so if I go and hold on to that baby. Come on. Now I can tin the two side connections, which are tip and ring, and run my wire to both of them and solder them together. Okay, so those are both going to one contact. And then the front, which is the ground, goes to the other one. Now I don't have any, I haven't done anything about mechanical connections. I should be making little hooks and soldering on there so that it's got some strain relief to the connections. Okay, and you can do all that, but it takes time to do that. So what I do is, after I've got it all done, okay, I hit it with hot glue.
Yep.
So now my cable is fully encapsulated in the hot glue, and all the pins are too. So that's pretty much idiot proof. It's not going to fall off. And now I have the other two leads that I can solder. I can solder onto my key location. So I'll put this on. Now I can solder both of these now because I don't have anything really standing on there other than wires. Now I'll put black for the ground. Doesn't really matter. And the second one. Okay, whoops. I don't see that as being nice and float over. There it is. Okay, so hey, we're over the 50-yard line or whatever. Okay, so we're looking pretty good there. Next thing on here is another capacitor, 0.1. I'll do the same thing. I'll just put solder on one pad. I mean, this gets very repetitious. I mean, we're doing the same thing over and over and over again. Okay. So I'm gonna tin both feet, little feet. Put some solder on them so they go in nicely, and then turn it upside down. Seat it on that one pad. Wait for it to cool. And then I'm going to make sure that second pad is looking pretty good.
And move it back onto the X.
Move it back onto the X. Thank you, Steve. Sorry. You have a tendency to lose track of that whole thing. I guess I'm not a good actor. I can't stay on my mark, huh? Okay. So there's that one. So now we're left with one more transistor. Couple of things, a resistor, another capacitor, another resistor, and we're cruising here. So the next thing is probably over here at this 4.7K, which is one of the resistors that you want to be able to change. 4.7K. The higher the resistance, the lower the output power of this kit. Okay, so and I included three different values of resistor to use here. So I'm going to do the same thing. I will only solder one pad, and I will solder the corresponding, doesn't really make which one is it, but just solder one of the pins. I'm going to tin both, but you notice I've only got solder on one of those pads, so it's only got a solder on one side. So I'll get that thing centered centered nicely in the pad. Look at it, so it's nice straight up and down vertical. Looks pretty good. Very carefully pull that off. You don't want to pull it off too soon because if that solder isn't really set, you'll get a stress fracture on that joint. But that's why when we cool that down, I can go over and make sure. Yeah. I'll add some more heat, a little bit more solder. Now make sure that first pad is done right. Okay, and mind you, this is where you're going to pull that resistor in and out, so you have to be kind of careful with that. You want to make sure that any plug-in has got a really good connection to it. Okay, so we got one more transistor left here, and that should be the 651, and that one would be the other one that's remaining up here. Where the heck did it go? that's not it. The 651 is instantly recognizable because it's very flat. Where'd it go?
What's that down below?
Ah, right there. Yep. It was over there with all the other transistors having a little transistor party, I guess. I'm just gonna double check it to make sure it's make sure it's the one I wanted. Yep, 6 on it. Okay. So I'm gonna do the same thing. Now you notice that I have 2 sets of pliers here. One with the rubber band and one that's not. And these are my favorite pliers. Remember, those are my favorite pliers. So I don't have to keep taking the rubber band on and off. And
Did you get those at Harbor Freight by any chance?
No, I did not.
Oh.
These come from Jameco Electronics. And I've
Ooh.
recommended them many times. And they're non-magnetic.
Except for
Yes, they are.
except for when they grab the tripod.
Except when they grab their tripod. So there's.
So they're magnetic.
I thought they were not. I thought they were non-magnetic. I thought they were actually stainless steel. But that might have been the. Okay, so again, I flared it out, made my little tripod, and I can see it fits nicely. This one's a little bit offset, just a little bit more, and I can see dry fitting. That's the important thing when you're doing these. I dry fit it, and I see it fit nicely on all 3 pads. So I'm gonna go and do the leftmost pad because I'm on the right hand side. I'll do the leftmost pad. And I pulled off some solder and I've got 2 inches left. I'm almost there, but I'm gonna run out. Leftmost pad. Get my little vice pliers out. Again, I'm gonna tin all 3 leads while I've got the transistor held by my pliers. Okay, I can't set it down that way. I gotta move it because I got that socket resistor in the way, so I gotta come down vertically. And I'll make sure it's sitting on my little pads. Okay. Looks good. Very cool. Very carefully. I'm gonna get some more solder here. Where's my solder? Maybe another 6 inches. So now I can't go and resolder that now because it's the only lead that's soldered. So I'm going to go hit the other side. Make sure that guy is plunked down. I'll do a little bit of wicking action on the lead. Blow on to cool it down. Do the 3rd connection while that's cooling. And I got two leads now. I'll go back and hit that first one. Just make sure that. Yep, I like it.
Yep.
Okay, there we go. All right, so now we got another capacitor. So here we go. Here's another 0.1 capacitor.
Slide down a little bit onto the X when you get a chance. There you go.
Okay, X is the capacitor. Getting the leads. Solder 1 pad. Nice big dab of solder. Turn this upside down and I like it. Okay, now the other side fits pretty good. I'll hit that. Go back. Now I know it's up there good. I'll go back and just hit the other one again. There we go. What do you got? 1, 2, 3 parts left.
Can you turn the board how you just had it? Yeah,
Right there.
there you go. Perfect. Yeah.
That look good?
Yep.
Okay. All right. So now I got a 100K. This one should have feet on it. There it is right there, the feet. That's the important about, doing some homework, prepping these parts so that when you're actually doing a build-a-thon, a lot of the jury work is already done, so you can just straightforward go build. I kind of like that. All right. Make use of whatever's at hand. I got a nice anchovy tin here, so I've got my thing propped up so I can do both of them at the same time. Always looking for a good way of making it easier to solder. Okay, go in from the top. Get that first foot right in the middle. Okay. I can see that thing sort of folded over on me. I'm gonna wait for it to really get cold, and then I'm gonna straighten that angle up and then come back down on the other side. Okay. Yeah, not the most beautiful connection, most beautiful bent job there, but it works. Okay, I'm gonna hold that foot down. I'm gonna do my little trying to get that to wick up on the lead nice and neat, and there it is. So now we got a little variable capacitor trimmer cap, and we're using this trimmer so that we can rubber the crystal and move it around a little bit. Okay, so all the old circuits rubbered their crystals. All right, I've done another inch of solder. I guess I gotta get some more. We do chew up a little bit more solder with this type of construction, but still, it's pretty easy to do. And I'll tell you, I'll give you the hint after we've got this thing done. Because I sent one of the first of these Limerick solder kits down to Dave Ingram. Trying to remember his call sign. K4TWJ, I think it was. He used to write the CQ, the QRP column in CQ magazine. Big builder. And I sent him down the first of these Limerick construction kits I had designed, and he thought it was just, I had designed the kit to work on 30 meters, and he instantly was able to mod it. Did I tin both of those leads? I don't know. These leads are pretty short, so I got a very fine tip on my iron, and I'm going to get right in there and same thing. I mean, you just have to be able to get underneath the part. So with a very short lead. There's the second lead. Now I'm going to go hit the first one again. Make sure it wicks up on the part. Hey, we're down to the last part. This sucker's almost all built. Now we've got the crystal, which is in the 3-pin SIP socket. So we're doing the same thing. So I'll tin both of those pins. The middle pin has been cut off on this in this particular case. You can leave it on there inside of it, but that would make a very, very small pad for it. So I generally don't do that. The only reason you leave the center pin on because you can make a false ground to this crystal, and ground the case. But that means the pads down here are awfully close, and you can't really do that with this kind of construction. So I could put a third pad over here like the transistor, and then put a wire that goes up and clips to it, but it would make it hard to change the crystal. You notice I'm starting with the crystal in play because that's acting as a really nice handle for this thing. Okay. that kit is built. Everything is in play. Everything's there. So we're gonna fire this thing right up. I put a terminal block on here because it depends on what you have for your benchtop connections and whatnot. We have a car battery sitting over here, and I've got a jumper to it. My benchtop supply, I've got a barrel.
You've got a little X right there in the middle of the board.
Right there, I got an X. Okay. I have a barrel plug on my power supply on my bench, so we're going to put a barrel plug in here, which I happen to have. Where'd it go? Well, I had one. No, I didn't supply a connector.
Yeah, I was going to say.
Well, son of a gun. I could have sworn I had one. Oh yeah, here it is right here. It's actually in the kit I had pre-built before. So I'm going to unplug this from the terminal. And I'm going to put it, making sure I got plus to the right spot. Up top. Whoops, sorry about that. I'm going backwards. Okay, we'll pull that out. Put that in. That's doing a little bit of... Now, here's another case where I know I've got a good connection. So having some hot glue on this front and back side and, just sort of move it around.
Some stability.
Really stabilize this thing. So I will do that when I get home. I'll get my hot glue gun out. And I love hot gluing stuff together. One time we made a whole Halloween costume out of felt and hot glue for my daughter. She went on Halloween. I had just introduced her to the movie Ivanhoe. I better not tell this story because she doesn't like when I tell stories. It's a funny story though. I'm still laughing thinking about it. Okay, so we got power supply coming for this 12-volt battery. And I have a watt meter over here. I'll bring my really nice watt meter in. Okay, I will hook it. It's got a built-in dummy load. I'll hook it up to the RCA again. Another connector that could stand for a little bit of hot glue. I'll bring out my straight key, and I'll plug that into my key jack. And okay, then I will get my barrel jack and I'll plug it into power, and hopefully we don't get any smoke.
Poof. No smoke. Yeah, there you go.
What do we got there?
What range are you on?
We're on 1 watt.
So you're at just under 0.8.
0.8. Now that's with a, this is a, that's like a 4.7K resistor. I'm going to pull that resistor out. And I'm going to put in the, whoops, I got my power meter part on top of the parts, I think. Where's the other 2 resistors? Okay, here's a 1.5K. So I just pulled out the 4.7. I'm going to put it in roughly half, a third, 1.5. Ready for the magic number? Here's the magic will happen. Whoa! That thing got the 5 watts.
Wait. So, wait.
5 watt scale. That's a little over 2, isn't it?
Just under 2.5.
2.5. So we're getting 2.5 watts now. This little, I'm gonna hold on to it. I'm getting hardly any heat at all on this thing. Okay, hardly any heat at all. Yeah, it's a little bit, warm, but nowhere near self-destruct level. So you can see, you could probably drop that for sending code. You could probably drop that down to 1K.
Yeah.
And get close to 3 watts out of this thing. Yeah. That's friggin' amazing. Yeah. Now, here's the thing. Okay. I'm going to get this out of the way because I think we've shown what we needed to show with the big meter. Okay. Put this out of the way. And the thing is, if I had hardwired this into those 2 pads instead of had the little socket. Okay. Yeah. So here's a little socket right here. If I just hardwire wired this resistor socket. If I wanted to change the power level, I just basically put solder to it and pull the two pads, and the part is gone. I can put a new part in.
Yeah.
Without affecting anything else on the board, because nothing is going to fall out when you take that part out, because the only thing connected to those two pads is that one part.
Yeah.
And so when I sent the 30 meter, I think it was the first one I did ever was the Reggie, and it was a design. It was a QRP design by Michael Rainey. And he had done it at 30 meters. So I built this 30 meter kit, and I put them out there. And it was honor of, he showed up at LobsterCon that year. So I sent it down to Dave, and he built it on 30. And he says, and I remember the phone call I got from him. He was from Alabama, deep in Alabama. He said, he said, that mirror construction, that is slick. And he just pulled a few parts, just pulled them out, put new parts in, and he moved the thing to 40 meters, the same night. So he built it for 30, and then he moved it to 40, he modded it for 40, without really doing any much deconstruction to the kit itself. You didn't have to put anything on holes. You don't have to unsolder things that are stuck in holes.
You don't have to get the solder out of the holes.
Right. You don't have to suck any solder. You don't have to suck any parts. It is really great for experimenting and modding. So that is Limerick construction. And it didn't take us long. What time is it now?
8:02.
8:02. So it's less than an hour he built this thing. And that was the goal, was to have a simple design that works, and you can play with, and you can move it. You change the crystal. That's all you got to change is the crystal in the low pass filter.
Yep.
And you got it on a different band, because this is a wide band transmitter. Some of these early classic designs are just fabulous for playing with. And I love the X-1er. And you can go into there's not very many in the Sprat files. I only found 2 notations for the X-1er in Sprat, the original article and then something else. But there are other incarnations that are floating around. If you got George's books, QRP Basics, there are 2 versions of it, different versions of it, one in each of his books. When he mentioned the X-1er, I think there's probably one is the original, and then one is an updated with the 2907 and the 2222. Now that's the other thing. You could change the transistors and possibly get more power out of it. But geez, you don't need much more than 3 watts.
Yeah.
Out of this little thing sitting on. Oh, and by the way, I sit it on a Cento on a blue can. It's a nice little transmitter. I'm sorry, it's a nice little transmitter. Okay, and it matches perfectly with the red one, which is the receiver. Now, the thing about this is it's a transmitter only. Okay. And you don't have a TR switch on it, so you got to fab that. And you don't have a low-pass filter, which you absolutely need to meet FCC regulations, which is why there is another kit in the package. Okay, so this one, we're not going to build this tonight, but I'm going to put another video together. But this is, again, so easy to do. And this board is, in essence, a Manhattan-style board where you don't have to glue any pads down. They're all glued down. Because it's fabbed on things. So this is where you would build a circuit from scratch, going from pad to pad to pad to pad.
Yeah.
And this is the low pass filter that you would build on that. Now I may tip that up so you can see that I'm only using a small piece of that board.
Maybe
so
turn it towards the left. Yep. There you go.
Okay.
Yeah.
As you can see, I'm only using a small section of that board. You could have a second low pass filter on the top of it, so that you can actually have 2 bands in one, and you just change the crystal and you go into a different socket. So if I built this flipped it and built it this way with a different set of capacitors and chunks, I could have a 40-20, and I could just basically pop this crystal and put a 20 in there, and then crank it into the 20 side low pass filter, and I have a 2-bander.
Probably had enough room in there for your TR switch.
Well, too. Over here, all you need is a single pole double throw switch for a TR switch. Yeah. So you can do that over here. So and I'll publish this little circuit here. This low pass filter is in essence a 40 meter low pass filter. It's the same one you find on my Easy build. And I chose it because it's easy to build, because it only has axial chokes and capacitors. You don't have to wind any toys or anything like that.
Yeah.
So all you gotta do is figure out the layout, and you know what? That's geometry. I mean, that's crossword puzzle kind of thing. You just figure out what pad you want to use, and solder the parts. So I'll put a schematic of this thing and how I laid it out up on the site. I didn't have time to do it. I've been stressed all week on.
And you'll put it on this page here, the one that the
Yeah, it'll be up on the website. So
on the down at the bottom of this page, the one with the Cento one.
Yeah, you'll see the docs down below.
Yep.
Roll down there. Okay.
Yeah, it'll be down.
Okay,
here.
so there's the bill of materials, there's the homework prep, there's the jack fins. I'll add a couple more pieces to it. I'll add the low pass filter. I also, unfortunately, I couldn't get the link out of Sprat because Sprat really doesn't have links. So I got to copy the pages, but I was going to put the original x-1er circuit up on the article from Sprat. I didn't check with the Sprat people to see if it's okay, but I'm pretty sure it will be.
Yeah.
So I'll put that up there, and I don't think you need a video on how to build it, but I think you need an aid to figure out what pads to use.
Yeah.
And I'll do that.
Yeah.
So I mean, there it is. I mean, it's pretty simple to construct things, using this style of construction. I didn't bring a frequency counter. If we did, we could adjust that little capacitor, and we could move this crystal around a little bit, or the frequency around a little bit. You can see we can plunk that resistor in and out, and we can change how much power comes out of it. I mean, it's cool, and we only spent an hour building it, from start to finish.
Cool.
Okay, so that gets live stream number 4 out of the way.
I think that's it.
What are we gonna do with live stream number 5?
Yeah.
I don't know, but I got something coming up.
So,
I got another idea.
Stay tuned on the website
Well,
to see what.
I just want to say one more thing. I mean, we started off with the first live stream as a tuna tin. I mean, I had to start with a tuna tin, but we got a transmitter that was really nice, and then we got the accessory kit was the key. We got the dummy load. We got the RF probe for tools for building all the other kits. The second build-a-thon was the CB cider. Now, this sort of takes off from the early '76. The first article that came out was the Tuna Tin 2. Then there was the CB slider. Then there was the Hearing Aid 5, and that comes to they're not the same kits, but they're takeoffs of that. Okay, and that's instead of a Hearing Aid 5, that's a Sudden built in a different style, no solder. Okay, the fourth one is a transmitter built Limerick style. Okay, and the fifth one probably it might be surface mount. Okay, because I want to build it. I want to build it in the same style of tin, but it's a little bit bigger than this. It's like a sardine tin, but it's not quite as big. Because if you go look at sardine tins in the store, they're all ugly. I don't like to do ugly kits. I'm not going to put a label around this. I'm trying to make the kit itself stand out all by itself, and it will. So anyway, that's it.
Excellent.
I hope everybody stayed with us. I don't know what the comments were.
Yep,
we get a passing grade.
More. Yeah, we haven't had more. So.
Okay. I see
7 people
Campbell.
on
Well,
now.
this.
So.
Huh? How many did we have?
We got 7 on now. So.
7
dripped off.
Okay, they might have drifted off. Okay. Well, anyway, I hope this was worth it. Learning about a whole new style, learning a whole new kit. This is a nice little transistor. It set the QRP world on fire like 30 years ago.
Yeah.
I mean, so it's a nice little design, very simple, yet it performs. So,
And
okay.